Good day, sir. Okay, next topic is ideal and actual regenerative cycle. Number 1. They receive 68,000 kg per hour of steam by an ideal regenerative engine, having only one heater, of which the heater receives 15,400 kg per hour. The condenser receives the remainder at 0.007 MPa. If the heater pressure is 0.96 MPa, find the state, quality or SLT of the steam. A. At the heater entrance and B. At the condenser entrance. So, our solution for that, having illustration in order to answer in easy way. So A, point 2 at saturation, so the heater entrance is saturated. Letter B, answer is S2 equals S sub SAT at 0.96 MPa equals to 6.5991 kilojoule per kilogram. Okay, which equivalent in S sub 3. Getting the answer for it, S sub 3 equals SF plus X sub 3 SFG, and substitute the given 6.5991 equals to 0.55903 plus X sub 3 equals to times 7.7154, and calculating it, X sub 3 equals to 0.77767 or 77.77%. Next question. Number 2. Okay, next question. Number 2. A turbine with one extraction for regenerative feedwater heating receives steam with an enthalpy of 3373 kilojoules per kilogram and discharges it with an exhaust enthalpy of 2326 kilojoules per kilogram. The ideal regenerative feed water heater receives 11,338 kilogram per hour of extracted steam at 345 kPa, which equals 2,745 kilojoules per kilogram. The feed water condensate from the condenser enters the heater with an enthalpy of 140 kilojoules per kilogram and departs saturated at 345 kPa. HF equals 582 kilojoule per kilogram. Calculate the turbine output in kilowatts. Okay. So having again illustration and getting the value of X, H sub 1, H sub 3, M sub 1, H sub 2, H sub 4, and H sub 5. Getting the formula, getting the turbine output in kilowatts will be P equals M sub 2 close open parenthesis H sub 1 minus H sub 2 plus close open parenthesis M sub 2 minus M sub 1, again close open parenthesis H sub 2 minus H sub 3, and since H sub 1, H sub 2, M sub 1, and H sub 3 are already given and have value of it, so no need to get the value of M2. The formula is M sub 2 H sub 2 equals M sub 1 and H sub 2 plus close open parenthesis m sub 2 minus f sub 1 times h sub 4. So substituting it the given data and using transpose method and calculating it, so m sub 2 will be 18.559 kilogram per second. So since all the data was already given, we need to substitute it all. Our P or turbine output in kilowatts will be 18,112 kilowatts. Okay, next question, number 3. 10,000 kilowatts turbo generator operating at rated capacity receives 52,000 kilogram per hour of steam at 2.90 MPa and 310 degrees Celsius. Exhaust at 0.007 MPa at 1.20 MPa and 230 degrees Celsius. They're actually extracted 20% throttle flow for regenerative healing of feedwater. The generator efficiency is 95% for an ideal engine. Find A, the quantity of steam extracted kilogram per hour. B, work. And C, thermal efficiency. For the actual engine, find D, the temperature of feedwater from the open heater, E, and K, and F, the approximately enthalpy and exhaust steam and its quantity. Okay, having illustration and getting the value of H sub 1, H sub 2, H sub 3, H sub 4, H sub 5, WP sub 2, total work, and HP sub 5 is in the module. To how to get it? H sub 1 equals H at 2.90 MPa and 310 degrees Celsius equals 3022.32 kilojoules per kilogram. S sub 1 equals 6.605 and same process for other data. Next, M equals H sub 5 minus H sub 4 over H sub 2 minus H sub 4. Okay, since the following data is already have a value, M equals 798.33 minus 163.55 over 2822.83 minus 163.55, and calculating it, M equals 0.2387. Next, QA equals H sub 1 minus HB sub 5, and the following data is already have a value. So QA equals 3022.32 minus 800.265, and next move calculating it. So QA equals 222.055, and next A for M or mass equals 52,000 times 0.2387. So M will be 12,412.4 kilogram per hour. Next, B for W or work equals H sub 1 minus H sub 2 plus close open parenthesis 1 minus M, and again close open parenthesis H sub 2 minus H sub 3. This formula came in the module, so substituting it and calculating it, our work or W equals 798.33 187.3 kilojoules per kilogram. And next, C for thermal efficiency equals W minus total work over QA. By substituting it and calculating it, thermal efficiency is equal to 0.3530 or 35.3%. And next, for letter D, M equals 52,000 kilogram per hour over 10,000 kilowatts is equal to 5.2 kilogram per kilowatts hour. And next, for letter E, Mk equals Ng times M. This formula came from modules, so M equals 0.95 times 5.2. And calculating it, M equals 4.49 kilogram per kilowatt hour. And next, EMK equals Ng times Mk. Substituting it, Mk equals 0.9 times 5.2. By calculating it, Mk equals 4.94 kilogram per kilowatt hour. Okay, proceed for work or W equals 3,600 over 5.2, and by calculating it, W equals 692308 kilojoules per kilogram. T saturated at 692.308. Our H sub F or HF equals 163.869 degrees Celsius. Next, WK equals 3,600 over MK. And other one is NK equals WK over W or work. Formula for NK. Getting the answer for it by substituting it and calculating it. WK equals 728.74 while NK equals to 0.9256 or 92.56%. And next, but not the least, letter F, formula for NK equals H sub 1 minus H sub 3 over H minus H sub 3. Since we have data for it, we already have a value for it. It is time to substituting it. So 0.9256 equals 3022.32 minus H sub 3 over 3022.32 minus 2063.20. By calculating it, H sub 3 equals 2134 0.599 kilojoules per kilogram. So that's it. Okay, next, number 4. 25,000 kilowatts turbo generator is supplied with 128,000 kilogram per hour of steam at 2.5 MPa and 400 degrees Celsius when developing its rated load. There are actually extracted 10,400 kilogram per hour at 0.3 MPa and 8,300 kilogram per hour at 0.06 MPa. The condenser pressure is 0.007 MPa and actual feed water temperature is 107 degrees Celsius. For the ideal engine, find A, various percentage of extracted steam, and B, E for the actual engine, and C, find the various percentage, D for MK, E for EK, and F for NK. And next, G, find the approximate enthalpy of the exhaust if the generator efficiency is 96%. Getting the answer for it, having illustration for it, getting the value of h sub 1, h sub 2, h sub 3, h sub 4, h sub 5, h sub 6, h sub 7, vf sub s, vf sub 7, hb sub 7, and so on. Again, same process. Okay, a equals a is m equals h sub 7 minus h sub 6 over h sub 2 minus h sub 6. Okay, since we already have the value for it, for given in our problem, next move is substituting it. M equals 561.43 minus 359.91 over 2735.308 minus 359 minus 91 by calculating it. M equals 0.0848 or 8.48%. Next, M2, formula of M sub 2 equals close open parenthesis 1 minus M sub 1, another close open parenthesis H sub 6 minus H sub 5 over H3 sub minus H sub 5. Next, substituting it. So, M sub 2 equals 1 minus 0.848 close open parenthesis 359.91 minus 163.35, and by calculating it, M sub 2 equals 0.07804 or 78%. Next, for letter B, formula for work equals close open parenthesis H sub 1 minus H sub 2 plus close open parenthesis 1 minus M sub 1, another close open parenthesis H sub 2 minus H sub 3 plus close open parenthesis 1 minus M sub 1 minus M sub 2 close open parenthesis again H sub 3 minus H sub 4. And again, by substituting it and calculating it, work or W equals 991.156 kilojoule per kilogram. And for EC equals H sub 1 minus H sub 7 equals 3240.1 minus 561.43 equals 2678.67 kilojoules per kilogram. So next, E or our thermal efficiency. The formula for that E equals W over EC. By substituting it, E equals 156 rather over 2678.67. Next, equals to 0.37 or 37%. So next, for actual engine. So the illustration can be seen on the screen so that the problem can be easily understood to be solved. So 0.37 equals H sub 1 minus H sub 2 over H sub 1 minus H sub 2. By substituting it, 0.37 equals 3240.1 minus H sub 2 over 3240.1 minus 2680. And by calculating it H sub 2 equals 3032.863 kilojoules per kilogram. Again, same process. So H sub 3 equals 2.43.104 kilojoules per kilogram. Next, C. For C, M sub 1 equals H sub 7 minus H sub 6 over H sub 2 minus H G. And next move, substituting it, M sub 1 equals 561.43 minus 359.91 over 3032.863 minus 359.91. So by calculating it, M sub 1 equals 7.54%. And next, letter D for MK equals 128.000 kilogram per hour over 25.000 kilowatts. By calculating it, our MK equals 5.12 kilogram per kilowatts hour. So let's proceed for letter E. So W equals to close open parenthesis H sub 1 minus H sub 2 plus close open parenthesis 1 minus M sub 1, another close open parenthesis H sub 2 minus H sub 3 plus close open parenthesis 1 minus M sub 1 minus M sub 2 and another close open parenthesis H sub 3 minus H sub 4. So by substituting it, okay, and next by calculating it, we can get W equals 951.49 kilojoule per kilogram. So okay, next for WK equals 3600 over MK. So next for that is 300,600 over 5.12. So by calculating it, equals to 703.112. So next problem, next is EK equals WK over EC. So again, by substituting it, EK equals 703.125 over 2678.67. And by calculating it, we got the value of EK 0.262 rather, or 26.2%. So next for our letter F, NK equals WK over W for the formula of NK. So by substituting it and also by calculating it, we got the answer of 0.738 or 73.8%. So last for our letter G, NG equals N sub 1 minus H sub 4 over H sub 1 minus H sub 4. So by substituting it, we got 0.96 for the value of NG.
Okay, gangit ka mo di.
3240.1 for the value of H sub 1 minus H sub 4 over 3240.1 for the value of H sub 1, and for the value of H sub 4 is 2427. And by calculating it, so we got the answer for H sub 4 equals to 2459.5 kilojoule per kilogram.